All right, guys, we're going to go over displacement, velocity, and acceleration. And like any kind of physics topic, we end up having to do a little bit of math. So there'll be a few little math problems that we'll go through that help us get ready for this topic. Okay, so questions first, and we'll have these questions again at the end. What signifies how fast an object is moving and in what direction it is moving? So what is that term? What is the formula for force? What about net force? So we do have to know a couple of basic formulas. How do you find displacement? So we want to know what displacement is. And given constant acceleration, what is the formula for velocity? Okay, so we got a couple formulas to work out here. Okay. So as we get started, velocity signifies how fast an object is moving and in what direction it is moving, right? So that very first question, that could easily show up. How fast and in what direction, that's velocity. Speed does not take into account the direction in which an object is moving, while velocity does, right? Acceleration is the change of velocity as time elapses. And deceleration is simply a special case of acceleration that causes an object to slow down. Okay. Force equals mv. Should have said ma there. I don't know why it says mv. Force is mass times acceleration. Okay, and then we have a problem here, right? So if we are told that an object has a mass of 500 kilograms, starts from rest, and reaches a velocity of 15 meters per second in 10 seconds, what is the force acting upon the object? Okay, so first we need to find acceleration, right? So acceleration is v2 minus v1 divided by t, right, or time. And so v2 minus v1, so v1 is just the initial velocity, and v2 is the velocity after a certain amount of time here, right? So we see that we reached a velocity of 15 meters per second in 10 seconds. Okay, so that's the 15 that you see down there in the second line of our problem solving here. And we started at rest, right? So that's 0. So that's why we did 15 minus 0. We just divide it by 10 because it took 10 seconds. And then we get an answer of 1.5. Okay, and then we need to plug that back into our mass, right? Which was 500 kilograms. Multiply that by our 1.5 that we just found, and that gets us to 750 meters per second squared. Okay, and then some stuff here about displacement and average velocity. Displacement along a straight line has both magnitude and direction. The formula for displacement is final position minus original position. So a key point to remember here is that displacement only takes into account final and original position, not total distance traveled. And this will definitely show up in a question, if not two. So like, for example, if you ran around a track and finished right where you started, you just went all the way around one time, your displacement would be 0 feet. Okay. However, if you ran 500 yards in one direction and just stopped, your displacement would be 500 yards. So if you end up coming, you're always considering how far you are from your starting position, not necessarily how far you moved or ran or how far the plane went or anything like that. So again, you ran around a track, finished where you started, your displacement is 0 feet. Average velocity is just displacement divided by the change in time. I believe we'll get to that here in a second. I'll skip that one. All right, net force. Okay, so with net force, we'll say how much force is needed to accelerate a 750 kilogram vehicle 10 meters per second per second. Okay, so first of all, and we'll get to this kind of, we'll get to the answer. When you see meters per second, that means the answer is going to be in newtons. And if you don't know that, the answer may be a little bit confusing. So when we're looking at net force, we're just doing mass times acceleration. The mass is 750 kilograms, and the acceleration is 10 meters per second. So if you just multiply those together, pretty simple. From a math standpoint, we end up with 7,500. And again, when mass is in kilograms and acceleration is in meters per second squared, the unit of force is newtons, right? So we need both the mass to be in kilograms, acceleration meters per second, then we're going to end up with newtons, and our answer here is 7,500 newtons. Right, so like a likely answer choice that would be wrong would be like 7,500 meters per second or something like that. Right? That could easily throw you where you saw 7,500 twice. Newtons would be the answer that we want. And then finally, average acceleration. Okay, so let's read this one out. 30 seconds into our workout, Jennifer is traveling 15 meters per second. At 40 seconds, so 10 seconds later, she is traveling at 35 meters per second. What is her average acceleration from 30 to 40 seconds? Okay, so when we're looking at this, the acceleration is just change in velocity divided by change in time. So where you see that equation there, sometimes they're written in ways that confuse people, where it says A equals VF minus VI divided by TF minus TI. All it really means is A equals change in velocity divided by change in time, right? So she started off traveling 15 meters per second, 30 seconds into our workout, but then 40 seconds into the workout, she's traveling at 35. So we just go 35 minus 15, right? And that's going to be the change in velocity, so that's going to be 20. And then the change in time is just going to be the 40 minus 30, which is 10. And then you can see down there at the bottom, we have 20 divided by 10, and that's going to end up being 2 meters per second squared. Okay. So let's take a look here. We have our questions again, right? And so best thing here, hit the pause button and see if you can remember, especially the couple formulas that you need to be able to apply the formula for like velocity, force, net force, those kinds of things, as well as the key about how do you find displacement and what signifies how fast an object is moving and in what direction it is moving. Do we remember what that term is? If you got all that stuff down, you're probably in pretty good shape for this topic.